Hi there, Mr. Holtham here with another episode of The Math Behind the Modules. This is lesson 2 from module 3, generating equivalent expressions. Equivalent meaning they have the same value but aren't exactly the same. So the classwork for the opening exercise was to take the additive inverse, have a sum of 0. Fill in the center column of the table with the opposite of the given number or expression. Then show the proof that they are opposites. First row is completed for you. So we were given the expression 1. The opposite of 1 is negative 1. Additive inverse. Okay, so opposite is the same as additive inverse. Okay, just put that up there. And then proof of opposites, and we're going to add the opposites, and we should get 0, which is the additive identity. Okay? That's what proves something's an inverse. If you add two inverses, the answer is the identity. So the expression 3, we're going to take the opposite, negative 3. 3 plus negative 3 equals 0. Opposite of negative 7 is positive 7. Negative 7 plus 7 equals 0. Negative 1/2, the opposite is positive 1/2. Negative 1/2 plus 1/2 equals 0. The opposite of an x is a negative x. X plus negative x equals 0. The opposite of 3x is negative 3x. So 3x plus a negative 3x equals 0. Opposite of x plus 3 is negative the x plus 3 quantity. We need to be careful here with binomials. That's called a binomial. This is a monomial. Monomial. Mono meaning 1. Binomial. Bicycle, 2 wheels. Binomial, 2 terms. Minus x plus 3, if I distribute this through, I get negative x minus 3. So x plus 3 plus a negative x plus a negative 3 also equals 0. 3x minus 7, the opposite of 3x is negative 3x, the opposite of minus 7 is plus 7, so then I'd have 3x minus 3x plus 7 plus a negative 7. Okay, I can rearrange these any way I want because addition is commutative. 3x minus 3x is 0. 7 plus a negative 7 is 0. 0 plus 0 is 0. Okay? Okay, example 1, subtracting expressions. So we have the quantity 40 plus 9 minus the quantity 30 plus 2. The opposite of a sum is the sum of its opposites, and we're going to use orders of operations. Okay, so we have 40 plus 9. We can do it this way. Plus, because I want to change that to plus, but that's going to make this a negative 30. And then I'm going to plus a negative 2. That's minus 30, which is plus a negative 30, and then if I distribute that, minus a positive 2 is the same as plus a negative 2. So we have 40 plus 9 plus a negative 30 plus a negative 2, changing this all to addition. Okay. So 40 plus 9 is 49, plus a negative 30, plus a negative 2. PEMDAS says work left to right once we're down to addition or subtraction. 49 plus a negative 30 is 19, plus a negative 2, and my final answer is 17. Okay? If we did order of operations instead, it would have been 40 plus 9 minus 30 plus 2. And PEMDAS says to do what's in the parentheses first, or GEMDAS, the groupings. This would be 49 minus 32. And 49 minus 32 is still 17. Okay, subtract 3x plus 5y minus 4 minus 4x plus 11. We're going to do it this way first. So I'm just simply going to say 3x plus a 5y plus, it's a y not a 4, plus a negative 4. Careful with this minus. It's plus a negative 4x plus a negative 11. These are not like terms. Be careful. I'm going to rearrange this so like terms are next to each other. So I have an x here, and I have a term with x in it here. So I take 3x plus negative 4x plus 5y plus negative 4 plus negative 11. So I grouped all my x's, my y's by itself, and I put the constants together. So when I add these, 3x plus a negative 4x is a negative 1x, or just negative x, plus 5y, and negative 4 plus negative 11 is negative 15. This is the answer. There is nothing more we can do. We can't add x's to y's, and we can't add constants to variables. This is now a three-termed expression called a trinomial. Example 2. Find the sum by aligning the expressions vertically. All they're saying is take this and put it under this, lining up like terms. So I'm just going to take this 5a plus 3b minus 6c and rewrite it. And then on the next line, I'm going to put plus, and 2a goes under the 5a, minus 4b under the 3b, and plus 13c under the negative 6c. So my a's and my b's and my c's all line up. 5a plus 2a is 7a. 3b plus a negative 4b is negative 1b, or just simply negative b. And actually, if we want to show it this way, I guess that's what we've been doing. Plus, let me rewrite that. Plus a negative b, it's all addition. And negative 6 plus 13 is a positive 7c. Then we would clean it up and say 7a minus b plus 7c. I can't combine a's and b's, I can't combine a's and c's, I can't combine b's and c's. And I can't add these 7s because they're with variables. This is, I can't factor anything out because this doesn't have a 7. Okay? We'll get into that more in detail later. Find the difference by aligning the expressions vertically again. First, write your first term without parentheses. This is minus now. So I'm going to change this to plus and take the opposite of what's in here. And that's a positive 5x, so I'm going to make it a negative 5x. And that's a positive 2. So there aren't any y's, so I'm just going to put 0y here just to line it up. You can leave it blank, but I'll put a 0y. There are no y's, so 0 times y is nothing. And then we have a plus 2. And actually that's a negative 2, so it's going to be plus negative 2. So I'm going to put parentheses here, negative 2. Okay? 2x plus a negative 5x is negative 3x. 3y plus nothing, or plus 0y, is still 3y. And then plus -4 plus a -2 is -6. And we don't, and then when we're done, we want to get rid of our double sign. So it's -3x plus 3y minus 6. Okay, intro to word problems here, sort of. It's just a small, short 2 sentences. A stick is x meters long. A string is 4 times as long as the stick. Express the length of the string in terms of x. Okay? Well, the stick is x meters long, and the string is 4 times as long as the stick, which is x, so it would be 4 times as long as the stick, that is x meters long. So we don't need to show the dot, because a number next to a variable means multiplication. Now it says if the total length of the string and the stick is 15 meters long, how long is the string? Okay? The total length of the string and the stick. Well, what is the length of the stick? A stick is x meters long. The length of a string and the stick. So the length of the stick is x meters long. The length of the string in terms of x is 4x, so it's the length of the stick plus the string, which is 4 times as long as the stick, is, the word is in math means equals 15 meters long. So here's our equation. The length of the stick plus the length of the string, 4 times the length of the stick, equals 15. We can add these or like terms. 1x plus 4x equals 5x equals 15. And you can either show this as multiplying by 1/5, it's reciprocal, both sides, or if you had 5x equals 15, you can simply divide by what you're multiplying by. Whichever you choose is fine, because this is going to cancel, and that's going to become true. So we get the same answer either way you look at it. Divide by 5 or multiply by 1/5. Okay? So how long is the string? Now this is where it gets a little tricky. We have not answered the question yet. The stick is x meters long. The string is 4 times as long as the stick. We just found the length of the stick. So the string is 4 times as long as this. This is the string. And we got x to equal 3, so the string is 4 times that 3, which equals 12 meters. So you have to be really careful here and answer the question when you're done. And 12 plus 3 does equal 15. Okay, they didn't ask the length of the stick there, they asked the length of the string. Alright, example 4. It costs Margot a processing fee of $3 to rent a storage unit, plus 17 per month. Per means times, to keep her belongings in the unit. Her friend, Carissa, wants to store a box of her belongings in Margot's storage unit and tells her she will pay her $1 for the processing fee and $3 for every month that she keeps the box in storage. Write an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes. Then determine how much Margot will pay if she uses the storage unit for 6 months. Okay, so these word problems can get a little tricky, but you just have to be careful and work through them slowly. Alright, so we need to represent the number of months that the storage unit is rented. Okay, so it's $17 per month. So if it's 1 month, if M is 1 month, 1 month would be $17, and if M was 2, if there are 2 months, 17 times 2 is $34, and so on. It costs her a processing fee of $3, so it's 17M plus $3. Okay? The $3 is just the one-time fee at the beginning, so there's no times however many months, it's just $3 added on no matter how many months you rent it. So it's 17M plus 3 is what it costs Margot to rent the storage unit. But then her friend comes along and says, I will pay you $1 towards the processing fee, and $3 for every month. So that is going to reduce her cost by whatever $3 for every month minus the $1 towards the processing fee. So here's our equation. Okay? So now we're going to subtract by adding opposites. So it's going to be 17m plus 3 plus a negative 3m plus a negative 1, which is just plus 1. Okay? Combine like terms, 17m. I'm going to rearrange it first. So I put the m's together. Okay, here's the m, move that over here, move this 3 over here, 3 plus 1. And then I'm going to combine like terms. 17m minus 3m is 14m plus 3 plus 1 is 4. Okay. Oh, this should be a plus, by the way. 3m plus $1, not minus $1. She's not getting paid $1 in the processing fee. So that is one thing you should always do when you're doing problems, is check your work and think about what you're doing. And then I just realized that didn't make sense. So it's 3m minus 1 plus, or should I say plus a negative 1. And that would be, come out to be minus 1, which is 2. Okay. Just making sure. 3m plus a negative 3m plus 1 would be plus a negative 1. Okay, that's better. So she's going to pay for $14 per month plus $2 processing fee. Okay, now that makes sense. Okay? So there's my ending expression. Now we can, so there's our expression, write an expression. In standard form simply means all your variables combined, all your like terms combined, and simplified. That is standard form. Okay. Then determine how much Margot will pay if she uses a storage unit for 6 months. So that makes m 6. That means m equals 6. So it's going to be 14 times m plus 2. Okay. 6 times 4 is 24. Carry the 2. 6 plus 2 is 8. 84 plus 2 is 86. So that's how much Margot will pay if she uses a storage unit for 6 months. Now I'm curious, I could figure out how much Margot was going to pay for 6 months if her friend didn't store that box in there. So it would be 17m plus 3 equals some value. Okay. So let's not put the equal sign there. 17m plus 3. That's what she would pay right here. And for 6 months, if her friend did not store anything in there and she kept the storage unit, 7 times 6 is 42, 102 plus 3, which is $105. And then I could take what Margot's paying, subtract it from what she would have to pay if her friend didn't store anything, and I can find out how much her friend is going to pay. And that is $19 for 6 months. Okay? Example 5. Multiplicative inverses have a product of 1, which is the multiplicative identity. Find the multiplicative inverses of the terms in the first column. Show that the given number and its multiplicative inverse have a product of 1. Then use the inverse to write each corresponding expression in standard form. The first row is completed for you. Okay, so they gave us 3. The inverse is 1/3. The multiplicative inverse is 1/3. We have to be careful now. We can't just say the inverse. If it was the additive inverse, it would be negative 3. You have to be specific and say the multiplicative inverse is 1/3. Proof, show that their product is 1. 3 times 1/3 is the same as 3 over 1 times 1 over 3, which is 3 over 3, which equals 1. Use each inverse to write its corresponding expression below in standard form. Okay. So, multiplicative inverse of 5 is 1/5. The multiplicative inverse of negative 2 is negative 1/2. The multiplicative inverse of negative 3/5 is negative 5/3. The multiplicative inverse of x is 1 over x. Because it's a whole number, remember we think of as over 1. So if you flip it, it's 1 over x. And finally 2x would be 1 over 2x. Okay? So that's that step. Now let's do the proof. 5 times 1/5 is the same as 5 over 1 times 1 over 5 is the same as 5 over 5, which equals 1. Negative 2 times negative 1/2 is the same as negative 2 over 1 times a negative 1 over 2. Negative times a negative is positive. 2 over 2 equals 1. Negative 3/5 times negative 5/3. Negative times a negative is positive. 3 times 5 is 15. 5 times 3 is 15. And 15 over 15 is definitely 1. Here we have x over 1 times 1 over x. X times 1 is x. 1 times x is x. Anything divided by itself is 1. 2x over 1 is the same as 2x times 1 over 2x. 2x times 1, 2x. 1 times 2x, 2x. 2's cancel. X divided by x, 1. However you want to look at that. Okay. And then finally the last column, what are they doing here? 12 divided by 3 is the same as 12 times a third, which is 4. 65 divided by 5 is the same as 65 times 1/5. Okay, and then 5 goes into 6 once, 5 goes into 15 3 times. This is flip it and switch it, basically. 18 times negative 1/2, or 1 over negative 2. 18 divided by 2 is 9, positive divided by negative. 6 times negative 5/3. Think of this as over 1. Multiply, or we can cancel actually. 3 will go into 6 twice. 2 times negative 5 is negative 10 over 1, or just negative 10. 5x divided by x is the same as 5x over 1 times 1 over x. Okay? The x's cancel, and we get 5 times 1. 12x over 1 times 1 over 2x. Flip it and switch it. The 2 will make the 12 6. The x cancels the x. 6 times 1 is 6. 1 times 1 is 1. So the answer is 6. Okay. Relevant vocabulary. I'm not going to go over this right now. We did it in class. You can review this on your own. That's the end of lesson 2. Go do your problem set.